Section 2 deals with types of solids, and there's a lot of definitions here and a lot of description of just the different types of solids that we see in substances. So the first types are this is just looking at different classifications, and here are a couple of vocabulary terms: amorphous solids, and again, those aren't the molecules are not arranged in a very particular way, and so um, we can think of glasses and such. Crystalline solids we're familiar with. If you think of a crystal of salt, okay, ions, molecules, or atoms contain very ordered structures. Powders are amorphous. Crystals are crystalline solids. And so there are diagrams in the bottom. You can see this is very regular, and there you have an irregular shape here when we're thinking about the glass here versus the quartz crystals. And so some examples. So if we have pure quartz glass, okay, so again, we're looking at glass types. These two glasses in terms of Pyrex and quartz, they have low thermal expansion. So that's why they can be used in lab glassware and cookware, because if they get hot or cold, they're not going to crack. Um, and so, quartz is very good. It's transparent to a lot of wavelengths. Glass is good, but if it's clear to visible, but ultraviolet light is going to get absorbed. Soda lime glass, not really common because it's very easy to be attacked by chemicals, and thermal shocks and light. They absorb ultraviolet radiation. Um, Windows and bottles use this, but as far as in terms of a chemistry application, not so applicable. So as we continue to classify, so we have crystalline versus amorphous. There are other types of solids, and they fall into the types of bondings that we've dealt with. Ionic solids, uh, that is generally most ionic compounds. They're solids at room temperature because they have very strong intermolecular forces. And so there's alternating positive and negatively charged species, because opposite charges attract each other, and that's what holds these together very tightly. They usually have very high melting points. Molecular solids, all of the pieces of the solid are molecules. They're held together by dispersion forces if it's nonpolar, and by dipole-dipole forces if it is polar. Water is an example of a molecular solid. Atomic solids, they can either be molecular or just simply atomic. Metals generally are just a bunch of metallic atoms held together by metallic bonds, and electrons can flow between these. This is why they conduct electricity so well, and that's what this last bullet point deals with. There are also atomic solids that work out to be molecules. Um, and we'll describe those here in a minute. Network solids are another type of solid. Okay, the atoms are connected by covalent bonds, uh, and as it turns out, these are even stronger than ionic bonds if you have an appropriate network. Okay, so diamond, one of the hardest substances that we know, is a network solid. Okay, it is all pure carbon. So is graphite in the pencils that you write with. However, there's a big difference here because these are connected a little differently, and so graphite is not as hard as diamond, but they're made of the same thing, but they're connected differently. Okay, and this, I believe, is quartz, which can form a network solid as well. So this just highlights the type of uh, crystals and the types of intermolecular forces. So referring to this table is a really useful one to know what kind of crystalline solid you have, and if you can determine that, then you can determine what kind of intermolecular forces are holding those pieces together. And so there's a chart that goes through the listings of how you determine this. It's a flow chart. You ask the first question, is it an element or a compound? That's going to break you off. And then you continue to ask different questions, and the answers to these questions are going to bring you to what kind of solid you're actually looking at there. Finally, a sample problem here to determine the types that we have. And so there's a listing of 4. So iron is an element. So Iron is an atomic metal, so iron's going to be a metallic